with changes. We're postponing the discussion of the purchase of the water softener for the police department building, and instead replacing that with discussion of another change order on the adaptive reuse adaptive reuse project for the police department. And then there was in our packet a timeline for the capital budget discussion and approval. I wanted to just put after the wastewater treatment facility a brief discussion of schedules and maybe blocking out a potential second meeting. If we don't need it, we don't need it, but if we put it on everyone's calendar, it'll be there if we do. Dan, did you have anything else?
Else.
Okay. All right, so all in favor of the agenda as amended, please signify with a thumbs up. Okay, looks like we're all in favor. All right, approval of the minutes from August 13th, 2020. Can I have a motion?
So moved.
Thank you, Gary. Judy will second. Any changes, suggestions, Candy?
I think there's a comma missing in line 227 after fuel tank. I think it's a series of items and it needs a comma there. I couldn't understand it otherwise.
Okay. Change service line and control building to finding it. Okay. Do you have a
Yeah.
we could
Put a
add
after fuel tank.
put a comma after fuel tank. Okay.
Sense?
In the control building due to finding unknown footing wall and fuel tank for conduit and cable. Yeah, I'm good with that. Does anyone else have suggestions or changes? Don't.
I just have one thing, Beth, if you could just add, it's kind of moot at this point, but line 278, he said after further attempts to get the work done, he met with Mr. Cameron again in August of 2019. If you would add in August of 2019, it helps clarify the following changes. Takes us to the past rather than appears to be in the present.
Okay. I think that's a good addition. Does anyone have anything else? Okay. All in favor of the minutes from the 13th with those minor changes, please signify with a thumbs up. Gary, I can't see your, there we go, thank you. And so Luther, thank you, Luther. So we're 1, 2, 3, 4 in favor, 1 abstention, I think. Okay. Citizen comments. Oh, Eric's here. Hi, Eric. Did you hear the discussion on the minutes? You were voting, and did you want to vote on the minutes?
No, I missed the discussion.
Okay. All right, we'll just put you, we're good. We have a quorum, so we're all set. So both Lindsay and Matt are not here today, so you are welcome to vote today. All right. So citizen comments. Kathleen, do we have anyone for something other than agenda items?
I don't think we do. We have a few members of the Energy Committee, but I think they're here for the wastewater treatment upgrade.
Okay. Judy.
Yeah. I brought up the sidewalk part behind Mary Hogan, you know, going from the playground over to, I think it was Butt-Off Drive. And I was just wondering if, you know, if anything had been done about that.
So, Dan, do you want to give an update now, or do you want to wait?
Bill
under,
was gonna look at it, and I see he's muted, so I don't know if maybe he's gonna come on.
I did go take a look at it. Can't remember if I did a work order or anything, and I have not been back over. I need to go back and check it.
I was there a few days ago and it's been painted over
Okay.
like a square of light blue paint.
okay.
Well, quick comment while we're on that topic and location. The vegetation is growing in and over kind of the sidewalk itself. And there's also a private property on Butoff Drive with a significant overgrowth. Is that something the town reaches out to individuals to ask them to mow? Because those locations are getting pretty bad.
I haven't done that in the past. I don't know if we have a policy on that or not.
Maybe it's something we can take a look at and get back to people on, or just see where things are at.
Yeah, again, this one, I mean, the sidewalk that goes to Mary Hogan, I don't know if it's nettles or, but it's growing in and over the sidewalk. And then again, that private property on Butoff Drive is, the grasses are so high, they're basically crossing the sidewalk now.
Okay. So let's move, did anyone have anything else, or can we move on to project updates? Gary, was that a hand? No. Okay. So Dan, you want to take us through project updates for things not on the agenda?
Sure. Route 116, the Dow Pond Water Main Project, they started this week. Pipe got moved in, so underway. Construction period is about 6 to 8 weeks. The Drinking Water State Revolving Fund loans have been submitted to the state, and we received acknowledgement yesterday that they've received them. We have additional information to supply, and we will get that going to them. Hillsley Library Water Restoration Project. The 8 mid-sized windows on the parking lot side of the building have been removed for restoration, and other worker is working on the frames where those were mounted, and then the ones on the front of the building. So that's underway. Let's see, the other item is, I think Heather, you asked a question last time about East Middlebury Flood Resiliency Project. The permit has been signed by Kathleen and submitted. FEMA is almost at the end of tomorrow, end of the public comment period for environmental assessment. So we should be hearing from them shortly. And then also stream alteration permit was submitted on August 14, and that also has a 30-day comment period. So underway with that portion of the paperwork. I don't know, Kathleen, did I miss anything? Or?
Thanks, Dan. Does anyone have any questions for Dan on project updates? Anything further? Okay, let's move into the change order for the adaptive reuse police department project. Dan, do you want to take us through that?
Sure, there are 3 of them. The first one is for the, there's an alternate 2 on the original bid submitted by VMS, the contractor, earlier in the summer, and that was for a possible cost of $17,000 to reinforce the north wall of the cruiser garage. And of course, we wouldn't know what that really was going to be involved until we got the roof off of it. So anyway, long story short, it's not going to be that expensive. Instead, they're going to attach some 1/2-inch treated plywood to the inside of the masonry wall, anchored in. And that amounts to $4,344 instead of the $17,000. So I guess I can talk through all of these if you want, and then you can, the requester is just to have you recommend them to the board. So the first change order is for $4,344 for reinforcement of the concrete masonry unit wall. The second one is a deduct for deleting the 1x3-inch wood strapping on the underside of the cruiser garage. They're going to directly screw the plywood on the roof, on the inside of the roof, to the rafters to give a little better clearance for the door track. So we're going to delete that wood strapping. And that figure is $1,141 even. The third one is a change to the roof structure, and I included a little sketch from Nick, who's the architect, about that. And I don't know if you have a picture of this in your head, but on the south side of that control building, there was an entrance door that went into basically an enclosed, a patio that also served as a roof over the basement below of the digester structure. So if you look on the sketch, letter D is the south side of that control building. Letter C area is this pit. And so both of these tanks, round tanks on either side, were partially knocked down and filled in. So what we have is the area of letter C is basically a pit, and the area, the little square next to that, was where a bunch of valve vaults and chimney pipes or valve boxes and chimney pipes came out of that structure. The intent was to cover mostly just that square area. And we got looking at it, and it's like that pit just seemed to be a hazard, one for people or animals. They ever had a snake down in there. If someone fell in or crawled in there, they would have a hard time getting out. And if somebody accidentally locked themselves out of the building, they would be stuck in there. Of course, we're going to fix that with locks, but it just seemed to be a kind of a place if somebody wanted to, get inside that control building, they would have free access without anybody seeing them for a long period of time. So the architects came up with a design that will basically create a new roof from the letter D, if you will, that roof of the control building, all the way over to the left side to where letter A is positioned. So that whole pie-shaped piece sort of is going to be covered with a roofing material. Otherwise, we'd have to maintain a ladder and put in railings. It just got to be kind of cumbersome from a safety-wise perspective. So this change order is to do that roof, and I think I didn't mention too, it keeps the rain out and the snow out of there, and eliminates the use of having a floor drain in that little piece there where letter C is at. So anyway, the change order for this is $5,575. And so at the end of my paragraph, I'm requesting you to submit these to the select board for approval, and including these change orders, the project balance is around $95,547 and some change.
Okay, so thank you, Dan. When you say project balance, you mean what we had left of what we originally estimated, right?
Yes.
Okay.
Yes.
And should we do these recommendations as 3 separate motions, or can we put them all together as one?
I think you can put them together as one. Be fine.
Okay. So we have, so was someone willing to make a motion on that?
I'm happy to make a motion to make a recommendation to the select board for the approval of the 3 change orders as identified in Dan's notes. I think if my calculations are correct, for the sum total of $8,778.
Thank you, Luther. Is there a second?
I'll second it.
Thank you, Gary. Hold on a minute, I gotta get my screen back up. Okay. Any questions? Any discussion? Gary?
No,
Oh,
no.
okay. I see your
I was
hand move.
waving
No questions, discussions. Okay. All in favor of the motion, please signify with a thumbs up. Okay, it looks like we're all in favor. All right, thank you, everyone. Thanks, Dan.
Thank you all.
All right, let's move to the wastewater treatment facility evaluation report. Good morning, Dexter. Is he still with us?
I'm
Yes,
still with you.
I see you. Thank you.
Can you hear me too?
I can hear you.
That's good.
Just before you get started, I'll just ask all of the participants, committee members, and those just mute yourself while Dexter's presenting so there's not any background noise, please. And Dexter, I'll give you the floor and
Okay,
please fill us in.
I'll start my screen share now. If I can find the one I want. There we go. Does that look like Middlebury? Let's see, from the beginning. I just also mentioned that Steve Landry from our office is also online. And I've got another meeting at 11. It's a half hour away from me here. So I'm going to, I'll have to leave right at 10:30, but looking at the schedule, that should not be a problem. So we're here to present our, where we're at with the wastewater facilities studies. We have submitted a 60% report to the state and had a review meeting a month or two ago with them. So we're quite far along. We're at the point where we've done the evaluation, identified the needs of the facility, and we've made some, identified some alternatives, evaluated those alternatives. We'll discuss those today in the presentation. We've got a sense from DPW and treatment plant staff of what the desired options will be. So our plan is to head in that direction, but certainly value your input as we go along. Just, we're Tate and Howard. We were founded in 1992. I work out of St. Johnsbury, soon to be working out of Montpelier. So we're getting closer to Middlebury all the time. I've been the project manager in this project from the start, and Steve has been our project officer as well. The study had two basic parts. The first part being to evaluate the condition of the existing wastewater treatment facility. And the second part was to develop a plan to upgrade the facility. So the facilities we looked at consisted of the main pumping station, which is located downtown at the old treatment plant site. That facility does include flow equalization, which is a large tank that receives surges of stormwater, basically, that come down the sewer, would overflow without that flow equalization tank, but they're stored there and pumped to the treatment plant over time to prevent problems at the plant and prevent overflows at the pump station. Overflows do occur, but they are rare. There's also grit removal facilities at that pump station. It's a piston grit unit, and so that process is performed there as well. From there, there's a long force main that pumps up to the treatment plant site in the industrial park. There's a second grit removal process, which is redundant with the first one. And then the flow goes to SBRs, which are sequencing batch reactors. It's an activated sludge process. So what happens there is the wastewater is aerated, sludge is held and recirculated to maintain biological activity, and that's where the basic removal of contaminants or pollutants occurs before discharge to a UV unit, where UV light is used to disinfect the water to kill any bacteria and viruses that remain before it's discharged to the Otter Creek. There's advanced treatment provided in two forms. One is nitrification, which converts ammonia to nitrate and nitrite. Some denitrification occurs in the SBRs as well, which takes those nitrates, releases them to the air and form nitrogen gas. And there's also phosphorus removal, which is done both biologically and chemically at the plant. The biological phosphorus removal occurs in the SBRs, and as well as you add alum to the wastewater to settle particulate that also improves phosphorus removal. As we make the water clean, we remove solids from the process. We produce and remove solids from the process, and that's handled in a side stream. The solids go to a belt filter press where they're dewatered to about 20% solids, more or less. And then those dewatered solids, which is, it's called a cake form, it's like a wet soil, is moved by conveyor to a high temperature lime stabilization project, where a combination of heat and high pH is used to sterilize the sludge. That's a complex process with multiple machines within it, but the end product is a drier product that's suitable. It's a Class A product, which means it's suitable for public distribution. Middlebury's final project all goes to one farmer right now, and it's used agriculturally as fertilizer. And because it's got lime in it, it's got pH adjustment value as well for the farmers. This is a schematic of the wastewater treatment plant. I just throw it up there for fun. Let's see. Can you see my cursor when I move it around?
Mm-hmm.
Okay, so this is the main pumping station. This is where the grit removal occurs. There's a screen there as well. Then there are 3 pumps that pump to the main treatment plant. This is the grit removal at the main plant. The flow then goes to the SBRs, then to the UV unit, and then to the Otter Creek. The solids or sludge is removed from the SBRs in this brown line. They go to a sludge storage tank, and then they're pumped to the belt filter presses, and then they go off to the lime processing unit and off to the farm. This area over here, I didn't highlight it at all, but this is the septage receiving area. It's always been a part of the operation of this plant to receive local septage. If someone with a septic tank gets their tank pumped, the truck can take the septage here, pay a fee to the town, and those solids are brought in to the process as well. Let's see. This is a summary of what we found of the conditions of the plant. These are the process units I described to you above. If we go down, main pumping station, just a quick, I don't want to spend a lot of time on this because I do have a bunch of slides, but if there's any questions, I'm happy to take questions at any time or save them for the end. The main pumping station, grit removal, these are all the unit processes we reviewed. These are the recommended sizes compared to provided sizes. There is no deficit in this table. The site buildings are showing some, we put them in fair condition. There's just small things that need to be created. Some of the heating and ventilating systems need to be replaced. They're 20 years old, so you can imagine that they're not all working just right. And there's a lot of like building trim and building paint that needs to happen. Nothing major, just a lot of routine maintenance. The main pumping station size is adequate. With the grit removal, we did note that there's redundant grit removal at the treatment plant. The unit at the treatment plant is showing a lot of wear and corrosion. So we'll be recommending to eliminate that plant and that process, that equipment, and just rely on the equipment at the main pump station. The SBR really just needs a mechanical upgrade due to age. The controls are candidates for upgrade as well. The UV system, actually there is a deficit there. The provided capacity does not meet the existing, and there's no redundancy in the plant. So if the UV unit was to go down, there'd be no disinfection. And actually there's 2 UV units. So if one goes down, you'd get half your disinfection capability. The standard is that with your largest unit out of service, you should be able to meet your treatment requirements, and that level of redundancy is not there. And that's a risk to the town that we feel should be corrected. So the outfall is the pipeline from the plant to the creek. We have no known issues with that. Let's see. The sludge storage tank is properly sized. The dewatering units are 20-year-old machines, so they need some mechanical upgrade. We've investigated looking at rebuilding them and replacing them with alternative technologies. Similar to the residuals management, that's the lime processing unit. It's got a lot of corrosion, a lot of wear. It's at least due for mechanical replacement, which is quite costly, but we've looked at other technologies as well. And I don't have anything more to say about the buildings. So this table here, there's 3 tables here. This is a summary of the design conditions. There's a lot of engineering parameters in here that probably don't interest most of you, but they really interest us. We present them here for discussion. I've highlighted just that the design flow of the plant right here is 1.6 MGD. If we scroll down to the next table, you'll see that the actual flow to the plant is 1.0 MGD. So we also look at BOD, which is a measure of the organic loading, TSS, which is an inorganic loading of solids, and TP is the phosphorus loading from each of the sources that we've looked at, residential, commercial, and you've got a significant industrial flow to this plant, septage as well. We added side streams in our analysis. It's kind of a funny parameter, but it does impact the sizing of the treatment units. It was not considered in design, but the treatment units do see that process, that process flow, but it does not always affect the outflow or the discharge flow, because a lot of it is a load that's created internally. So I like this table 212. It shows you generally where the plant is at, design versus actual. So these numbers are the actual flows and loadings as a percentage of design for all of these parameters. So bottom line, the plant is roughly 65–70% of design capacity. That's a really good place to be at 20 years of age. We looked at projected flows, and there's not a lot of residential growth projected for Middlebury over the next 20-year period, which is our planning period. So we're really, that reserve capacity seems to be available for, you know, commercial or industrial growth and other purposes as well. So we're not recommending an upgrade to the plant for size. All right. Looks like I need to unzoom. Yes, Judy has a question. You're muted.
Okay, can you give an example of a side stream?
Sure. The most significant side stream comes from the dewatering equipment. So the sludge that's removed from the SBRs goes to the belt filter presses where it's dewatered. So it goes in at 98% water and comes out at 75% water. So that water that's removed in the dewatering process is returned to the SBRs. So that's a side stream that puts a load on the SBRs, but is not detected in the influent or effluent flow. It's not an added flow per se, but it's an added load. It's sort of an internal flow and load.
And are there any other examples, or is that the main?
Septage, I think, could be considered a side stream. There's smaller side streams too. There's an odor control unit that they don't use, but if it was in operation, that uses water to take odor out of the air from the sludge processing unit, and that would send a wastewater flow down. So, and then you've also got your building drains. We're looking at anaerobic digestion as an option for upgrade, and that has other side streams as well.
Okay, thank you.
Yep, I have to figure out how to get out of this.
Actually, if you don't mind, that also on that side stream, it's not necessarily just the flow, it's the load and the BOD that gets returned to the process that has an impact as well.
Right. Well, I was able to zoom, now I can't escape. I'm just gonna stop share and come back to this. Let's see what happens. Oh boy, let's see what happens here. There we go. I want to get back to where I was here. I was clicking on the screen, it kept taking me forward. Sorry about this. There we go. So now the next screen. This is just a summary of a lot of different flow parameters. Nothing really that interests you. I included this slide just in case it comes up. But again, the design flow is 1.6 MGD. The actual flow is 1 MGD. You're at 66% design capacity for flow. The other one that's significant is the peak hourly flow. It's designed for 6.2 MGD. You actually only see 4.5 MGD. That's because of a limitation in the pump station. The pump station is not able to meet the peak that it was designed. That's why the flow equalization was added to that plant. This is a summary of the industrial loads. You can see that Cabot cheese, or Cabot, all they do is a very high allocation of flow, 450,000 gallons a day. That's roughly that one facility is what, a little bit more than a quarter of the design capacity of the plant. Same with their BOD allocation is roughly a half of the plant. So your industrial contributions are very significant. So when we looked at the facility upgrade requirements, we wanted to address the needs that we identified before. We also had objectives that the town identified to look at biological treatment alternatives that will fit within the existing footprint. That is looking at alternatives to the existing SBRs. There was also a request to look at primary settling as a way to reduce the load on that biological process and more effectively remove pollutants up front. We've looked at alternative solids handling processes. It was actually the infrastructure committee that encouraged us to look at anaerobic digestion. So that's part of the plan. And we also considered chlorine disinfection versus UV disinfection.
Question?
Yes.
Generally, anaerobic digestion, is that a lesser carbon footprint in terms of electrical usage and off-gassing, et cetera, or?
I would say that, yes, that is true. We did not do an analysis of the greenhouse gas emissions for this process, but we did look at energy recovery from the anaerobic digesters, and it was part of the consideration of the town. And when we get to the end, you'll see that we're recommending anaerobic digestion, and it was preferred by the town, I think, because there's a perception that it would have reduced greenhouse gas emissions.
Well, and the use of so many blowers is fairly inefficient.
Yes, generating the electricity on site would probably have the greatest influence on greenhouse gas emissions on a global scale. Yeah, and we have some, we present the energy recovery costs. We didn't, I know you mentioned heat recovery as well. I think there's some opportunities for heat recovery, but it's small. It may be worthwhile when we get into design to look at that more closely. But for now, we neglected it. We looked at 3 primary treatment options: circular clarifiers and rectangular clarifiers. These are settling tanks, so they're 12 to 14 feet deep. The water comes in, the solids go to the bottom. The solids are removed as sludge, and the clearer liquid goes on to the biological process. There's room near the headworks for these, which works well with the existing site layout. The rectangular ones fit a little better because space is a little bit limited, but either one would work. But because the rectangular clarifiers would have common wall construction, it becomes a more effective structural option. And that makes that the lower cost option. We looked at a third option, which is just a mechanical drum filter. So the wastewater flows through a rotating screen. And the screen removes the solids, and the clearer water goes on to the, excuse me, the SBRs, or biological process. That was a more expensive option, but it was viable, so we considered it. Biological treatment, we looked at 3 basic options. The first option 1 is to keep the SBRs. And with this option, we also looked at the possibility of using primary clarifiers ahead of the SBRs. Option 2 is a MBBR. In this case, it's a mixed bed biological reactor or moving bed. So it is an activated sludge process with a media within the reactor that also provides for fixed growth. Now, aerated sludge produces suspended growth, and fixed growth grows attached to media, like a trickling filter or an RBC, or processes that use that. MBBRs are a hybrid of that, where they put a media in the aeration tanks, and it's more effective use of volume and space. So we looked at that as an item that might possibly fit within the footprint. Did Gary have a hand up?
No,
All right,
stretching.
you were waving.
I'm stretching.
The third option we looked at, we call AO. It is a process that alternates between anaerobic and aerobic treatment. We gain energy efficiency by using anaerobic processes which don't require air and high power to function. So we get the maximum benefit of that. Plus we get the required or necessary aerobic treatment to complete the work. The process we're looking at is called a 4-stage Bardenfo. And we looked at all 3 of these options with and without primary clarifiers. So this is a list of the treatment parameters. So one thing to note here is number of basins in service. The existing plant, which would be option 1A, to just keep things as they are, has 4 SBRs. And each of the other options would only use a portion, would not require use of all 4 of those tanks. So not only would they fit within the existing footprint, but they would free up the other tanks for other purposes. All of these processes, provide the required treatment for BOD, TSS, phosphorus, and they all provide nitrification as well. The nitrogen removal is not required by the permit, but nitrogen removal was built into the current plant 20 years ago. So it has been Middlebury's practice to remove ammonia, reduce ammonia to nitrate, nitrite, and they have provided additional treatment in the form of denitrification as well. So we have left that as part of this, part of the plan to continue to nitrify, even though it's not required by the permit. 20 years ago.
Question.
Yes.
You say it's not required by the permit, the current permit. If we were to do such a significant upgrade, would you anticipate new permit conditions which would require it, such as, you know, coming up to current code and treatment guidelines?
So that depends on who you talk to. That was the thinking 20 years ago, that it would be a requirement by now. It has not become a requirement yet, and there is no specific plan to make nitrogen removal a requirement in the future. Nitrogen in the effluent and nitrogen in streams has just not been identified as a water quality issue in Lake Champlain. The focus in Lake Champlain remains phosphorus, and nitrogen is not regarded as a problematic contaminant.
Thank you.
So it's a roll of the dice. I think that what Middlebury's done the last 20 years in treating for nitrogen is an honorable thing. Your wastewater treatment is quite affordable as far as your cost goes compared to other towns. And you're providing that level of treatment at an affordable cost. So I applaud you for that. And it's something that Bob Wells at the plant is proud of and wants to continue. I think it's a good thing. All right. So these are the costs of those different options. They have different, because they're different configurations, we're fitting them into existing tanks. They all come up with different design flows. So the first line here shows the design flow. The current plant is a 2.1 MGD design flow. All the options provide at least that, but a couple of the options, 1B and 2B, both provide, well, 2A too, slightly, but 1B and 2B provide a much greater amount of hydraulic capacity, treatment capacity. So we've estimated the cost of all these. We've looked at power savings. We've added an energy credit for the anaerobic digestion option, which providing primary clarifiers makes a slight improvement in the amount of energy that's produced by the plant. So we gave a credit for those three options that had primary clarifiers for that. This line here, total, is the total operating costs. It's not the, I don't think it's the whole plant operating costs, but it's the operating costs that are specific to these processes. So like the sludge processing is separate, and we analyze that separately. We do a present worth analysis. So we calculate the present value for 30 years of the O&M, and add that to the construction cost from above, and we get a total life cycle cost. So our recommendation on cost-effective basis is to look at the lowest life cycle cost. And we look at option 1B, the SBRs, as the lowest, and option 3B, AO with the primary clarifier, as being slightly more, but competitive. So we also note that the freeing up of tanks has value and reserve capacity. If this number was greater than the 2.1, we gave a credit. And if tanks were made available under tank reserve, we gave a $2.50 per gallon for making that space available to other processes. So all that's configured in this bottom line. The three options with the primary clarifiers are all quite close in life cycle costs with those credits. The option 3B is the preference of the operators. Their words, I think, would be that it's because it's a flow-through system and the SBR is a batch system. One of the problems they're having with the SBR plant now is that the SBRs operate on 4 cycles per day, and there are 4 tanks. So what's happening at the plant is each tank is developing its own biology based on the wastewater it sees during its specific time of the day. And because of that, all the sludges are different. All of the chemical requirements are different. All of the air requirements are different. And there's just no good way for the, well, I think the operators find the best way possible to deal with that, but it's not possible to address all those conditions optimally because they're all different. So the flow-through process would create one biology that would be consistent throughout multiple reactors and would simplify or eliminate concerns that they're having now with the SBRs. So we looked at the open channel UV and closed UV. So the open channel UV is what they have now. They're concrete channels and the lights are submerged in the wastewater. Enclosed UV is the UV lights it's an enclosed system that gets connected to the hard piping. So effluent piping would be required to collect the wastewater and run it through the lights. It's a lower cost option. And the third option we looked at was the chlorination. And with that comes dechlorination because we can't have a chlorine residual going to the creek. So we need a second chemical process to remove the chlorine after the disinfection is done. So
Question, does that account for all the disinfection byproduct rules related to chlorine and treatment of? Or is that just in drinking?
I'm not aware that, you know, the disinfection byproduct rules apply to drinking water.
Yeah, okay.
And organics in drinking water are a source of disinfection byproducts. So it's not regulated for wastewater discharges.
Okay.
So we just looked at it strictly from the standpoint of being an effective means of disinfection that'll meet your permit requirements. Chlorine dechlorination has the highest cost. This cost does not consider the savings that would be realized if we reuse a SBR tank, and that possibility is real. So that's like a $200,000 credit for that tank. But anyway, even without that consideration, the operating costs, because chemicals are cheaper than power, they're not as friendly to handle as a user, but they are cheaper than power. The bottom line is that on a cost-effective basis, the lower chemical cost relative to power makes chlorination, dechlorination a much cheaper option. I think the decision was made 20 years ago to go UV. I did this at a lot of plants that I was involved with at the time, and operators just wanted to get away from the chemical handling and preferred the UV for that reason. The operators today are handling chemicals all the time and finding that keeping the UV units functioning because they're highly automated, highly electronic devices that just don't last. They're harder to maintain, harder to service. The bulbs, you know, changes in technologies of the bulbs, the equipment they have there now is basically obsolete. They've had to find a custom source for bulbs that they're getting a good deal on because the original manufacturer has sort of discontinued them, still sells them, but at an exorbitant price. So keeping the UV units has been keeping the UV units running has been a real challenge for the operators. So that's a motivation for change.
Question, does this factor in kind of the increased corrosivity of the use of chlorine and storage of chlorine and such? Do you need a separate room or air handling to?
Yes, yep, we did provide a new chemical storage building with the chlorine option.
Okay, so it'd be separated and not a corrosive environment on existing.
Right, right.
Okay, thank you.
It's its own specific environment protected appropriately. Yeah, Judy.
And as far as, and sorry if I missed this, as far as efficiency, you know, if you run a sample through chlorination and you run a sample through UV, are they equally efficient in removing pathogens?
I'd say yes, they are, and I think that the chlorination is more reliable. There are issues with the function of the lamps. They get dirty. The light transmittance goes down. Sometimes it's hard to clean them first try. And there's not a good way to control them when you get into a problem. The chlorination is much more reliable and easier to correct or address problems.
And is any kind of analysis then done as to what might still exist in the water that's being turned over to the creek?
Yeah. There's E. coli is the measure. So they check E. coli in the effluent. I think that might be done daily, but it's routinely.
I think it is. So I have one other question, and I don't know if it should be brought up now or at some other point, but there are a couple other chemicals, PFOAs and PAH, polycyclic aromatic hydrocarbons. I'm concerned that testing of them is not required, particularly since both are carcinogens.
Mm-hmm. I'm familiar with PFOAs. What's the source of PCAHs?
Tar, fossil fuel products.
So is that like toluene, xylene, that kind of stuff?
I think so. And it's in all the driveway sealants that are put down.
Okay, so I'll tell you that and I wish Bob was here, maybe Dan knows, but there's been some testing of PFAs at the plant. They've tested both the sludge and I believe they tested the wastewater as well. And the good news is that Middlebury came up clean everywhere. So that has not been the case for other towns. And towns that receive septage are more likely to have PFAs found. But Middlebury, received septage and still came up clean. So that's good news. And I also think good news is that PFAs are sort of a chemical of the past, a legacy chemical. And I think that there'll be less and less of it in the environment moving forward. So less and less of it coming down the pipe. It's not anything that's produced at the plant. It's something that comes down the pipe to the plant.
Right.
Other chemicals, other organics that you mentioned, there is periodically it's called a wet test, a whole effluent toxicity analysis. And I believe that considers, the toxicity of the effluent as it leaves the plant.
Okay, because
I can't talk too much about the laboratory process and how it's done, but I know it's like every 5-year thing, there's an EPA requirement that the whole effluent toxicity be analyzed.
Okay, because I checked with Bob, and I'll go back to his email, but I was certain he said neither of those chemical groups is tested for.
So the whole effluent toxicity is not specifically testing for those organics, but the purpose of it is to detect whether or not there's something in the effluent that is toxic. It's called a wet test. And if you want, you and I can engage Bob in email and we can talk more about that. And the PFA testing has just been done in, I think this calendar year, maybe late last year, but it's all within the last year. So that's all new. And it's a one-time thing. There is no requirement that it be ongoing at this point, I don't believe, although that's a moving target as well.
Yeah. Okay, thank you.
Yeah.
So, excuse me, Dexter, before you get started again, you mentioned you had a meeting at 10?
Oh, it's at 11.
Oh, I'm sorry. Okay.
10:30. What do we got? Oh, yeah.
Okay. I'm sorry, I misunderstood. I thought you had said 10, so
Yeah.
keep going.
I think I'm near the end.
Okay.
Everybody kind of reacted.
Sludge dewatering options. So in the let's see, the first column is a centrifuge, but we identified a number of different options. Centrifuge is a mechanical device that rotates at high speed to separate the solids from the water. The belt filter press
Onto them for a while, just, you know.
rehab is the fixing the existing equipment that's there.
Okay.
Putting in new belt filter presses is an option. And we looked at a fan press, which is a rotating device, low speed rotating device that removes, separates the water from solids. And again, a screw press as well that works more from compression. I guess they all sort of work from compression to squeeze the water out of the sludge. So these are the options we looked at. The two lower cost options being fan press and screw press. New centrifuge is competitive, but was discounted because of the higher energy use. It's about 20% more energy use than the others. And the desire to get away from the belt filter presses, although they are the lowest energy costs, they use an awful lot of wash water. So you see the water cost there, $45,000 a year. Right now that's town water that's used to wash those presses. And there's a desire to discontinue that from a water efficiency standpoint. So those are the technologies we're looking at. Right now, Bob is trying to get familiar with these two technologies. They've got a screw press company, I believe, going to come in and pilot next week.
And either of those new options has presumably fewer moving parts than our existing one. The belt filter press has been problematic, that, you know, any belts and assemblies are challenging to maintain and operate. Right.
They have 2 or 3 belts, but probably 20 or so rollers, a lot of bearings that wear out. They're still a viable technology. Another benefit to the other technologies is that they're enclosed. The belt filter presses are open. So the environment in that room is unpleasant. And then going to an enclosed unit eliminates that and makes the space much more operator friendly.
Thank you.
Yeah. So for solids handling, we have this table here. I'll just describe the options that we looked at. Option 1A is high temperature lime stabilization. That's continuing with the existing process. Option 2 is going to a dryer. All of these processes will take dewatered sludge. No, not necessarily. I won't say that, sorry. Option 2 is a dryer, so that would take dewatered sludge from 25% solids, 75% moisture, and make it 90% solids, 10% moisture. In that process, the sludge is pasteurized. It's heated to over 212 degrees and sterilized that way. Option 3 is a liquid process where the liquid sludge would go to the ATAD, which stands for auto thermal aerobic digestion. So it's like a liquid composting process. So air is added to liquid sludge in digesters and it is stabilized that way. It does achieve a required temperature for a period of time to produce a Class A sludge. All of these options produce Class A sludge, which would be sludge that could be distributed for any use after stabilization. Option 4A is anaerobic digestion. There, under anaerobic conditions, the sludge is heated and stabilized. It heats itself with the methane it produces and produces excess methane that can be used to power the plant. AD plus is a is anaerobic digestion with a higher temperature pyrolysis process ahead of it. So it works on a smaller footprint. We looked at composted sludge in composting sludge in two processes. One is an agitated bin, enclosed structure. It would be multiple bins that would be like 10 feet high by 10 feet wide and over 100 feet long. There'd be a mechanical mixer that would move the sludge through the bins in about a 14-day process. Windrow composting, option 5B, is the opposite technical extreme, where we just pile up the sludge with sawdust in an open building. You've got space available, so that's viable. Those are the options we looked at. We considered construction costs, what's presented in the first 4 lines. They range from windrow composting as being the most expensive construction cost of 13 million, 12.8, and the cheapest being continuing with the existing lime process, 3.3 million. Then we look at our operating costs, power, chemicals. You see the lime process uses a lot of chemicals in comparison to the others. The compost doesn't actually use chemicals, but we use sawdust and wood chips to make the composting happen.
Question.
Yep.
When you do these analyses, and I know it's preliminary, have you engaged with Efficiency Vermont in terms of what credits may be available that would help subsidize the project for certain alternatives?
We haven't yet. We've tried to reach out to Green Mountain Power a couple of times and have not been able to engage them, but we particularly interested in what they can offer for energy sales and credits. But for now, the energy, when we get down to the energy production line, you'll see a $200,000 credit for anaerobic digestion. And that is offsets the operating cost of the plant. So the economics of energy production with this option is a no-brainer. You would be offsetting your own electrical cost. So there's really no need to engage with them in a market standpoint.
No, just, I've done projects with Efficiency Vermont at the college, and in the preliminary design phase, as part of our life cycle cost, if you can factor in, you could get a couple $100,000 potentially in incentives or, to learn that helps sway the present worth analysis for what it's worth.
Yeah, well, it's something that we intend to follow up on. Again, we're at the 60% phase stage of the project, so that's a good call, and it's something that we plan to do.
Okay.
This is Richard Hopkins. May I ask, make a comment here? I'm not a member of the committee. I'm a member of the Energy Committee. The Energy Committee is interested in getting the town's buildings off of fossil fuels for heat. And currently, the two occupied buildings at the treatment plant are heated with fuel oil. So we're very interested in the possibility that the two buildings could be heated with the products of the anaerobic digester, and that would be another savings by not buying fuel oil, instead using the methane generated on site.
Yeah, I think that's a real possibility. I'm not sure the annual heating costs at the plant, but I think it's small relative to the power cost.
No, it's small relative to the total wastewater treatment plant, but it is substantial compared to, it is of comparable magnitude to other buildings that the town owns.
Yeah, no, I think that's a real possibility. And that there's multiple ways that can be accomplished. And we would, inherent in what we do would be maximum heat recovery off the anaerobic digestion process. So not only methane, but also thermal heat recovery as far as cooling the sludge. So we would embrace that idea and make it part of the recommended plan.
Thank you.
And we can be, when we do put the recommended plan together, we will highlight that. So this table is duplicated in the next table. But this one we add what we call SSO, and that's source separated organics. And what that is food waste. Ideally industrial food waste, but we would like to open the door to other types of food waste as well. So what this is really just a financial model at this point, but it considers that we double the amount of solids that are processed in this unit by bringing in outside food waste. There's a huge benefit down here in increased revenue. I mean, at capacity, you could see $1.8 million per year of increased revenue. It also doubles your energy production to 400,000 a year. At that point, you would have energy to sell to the grid, and plenty of heat for the whole neighborhood, right? And, with these types of credits, we have life cycle savings, tens of millions of dollars over 30 years. So,
question.
Yes.
And maybe Luther knows more about this than I would, but I've heard tell in relation to the digester down at the Goodrich Farm in Salisbury that they also anticipate taking food waste from quite a large area, perhaps. And so I'm wondering about the supply of food waste and whether that might actually be an issue going forward, where it would come from and would there actually be enough to fulfill the numbers that you have here.
Yeah. So we have that same concern. We think that this is a good long-term plan, but perhaps the thing to do is to build the facility without it. The previous slide. Build this, start to receive SSO, and if it's there, you can upgrade to this model. I think that the bottom line, it's ATAD or anaerobic digestion are the two winners here. You'll see that ATAD does not produce energy, but anaerobic digestion does. So that's the basis for the town's wastewater staff preferring anaerobic digestion. And back on the previous slide, again, these are the two lower life cycle costs. So at either scale, it's the same technology. So we share the concerns with the possibilities of handling the food waste. One, the availability, and two, the complexity of the process, and feel that you could build this now, you'd be at like 2/3 capacity at this size. And if the material is there and the operation is successful, you could upgrade to this size later and realize the long-term bigger benefits of revenue and energy production. So this is an exciting part of the project for us. There's a lot of cautions in bringing in the SSO, a lot of considerations to be made. One is the market of the materials, of the availability of materials, and excuse me. Yeah, I'll be till about 10:30. Yep. Housekeeping. Yeah. So anyway, I'm going to move on. So these are the preferred alternatives. The AO process with the primary clarifiers, chlorine disinfection, fan press or screw press for dewatering, and the anaerobic digestion. There's my next slide, my final slide.
Okay, thank you, Dexter. If you want to just stop sharing, then I can see everyone again. Thank you.
Yep.
So are there other additional questions at this point? I have a couple, but I wanted to open it up to the rest of the committee. I don't see anything. So my first basic question is, what is our timeline? So you said we're about 60% complete. What is our timeline for the rest of to 100% completion? And then what are we looking at? I know in parts of the report that I read about, 20-year equipment being, at or almost at its life expectancy. What are we looking for, do you think, on a time frame of when we need to make changes, implement some of your recommendations?
Yeah, I would say there's no emergencies at the plant. I think the town has been good in starting this process early. So we're ahead of the curve. We've appreciated that we've been able to go through our process diligently and thoughtfully and slowly and move from step to step. I think that Dan's plan is that this construction will not occur sooner than 2022. So we're moving forward on sort of a relaxed schedule still. Bob has had to replace some valves ahead of the SBRs that have been problematic and something that we would have upgraded in the plant. But it wasn't a major capital upgrade.
Is the preferred analysis that you've come up with also the least complex in terms of performing this work while the plant is in operation?
Probably the least complex would be to continue with the existing SBRs, but because there's 4 tanks, it's really, the upgrade should be able to be phased quite simply. And the other options all free up tanks. So it should be easy to stage the construction.
Howard, I see your hand up. Do you want to ask a question?
Yeah, if I could, please. The Energy Committee, we're planning on discussing this in our meeting next week. And I just want to know if it's possible if we can pass along questions to you, to pass along to Dexter regarding this study. So, for instance, things like what it would take to change over to the HVAC if, in fact, we were using the thermal heat and things like that, if that could be factored into the study, and maybe some other questions that might come up in our meeting when we discuss this next week. So if we could pass them on maybe to you, Heather, and you could forward it to Dexter. Is that possible?
I would ask, yes, I see Dan pointing at himself. If you would please forward your questions to Dan, then he can get those questions to Dexter.
Sure. Okay. Yep. Thank you very much.
So I know that Steve, I just saw his hand too, had put some questions in the chat. Did you see those, Dexter?
Yes, I saw those. I think they've come up naturally anyway through the presentation. So yeah, I've noted that and appreciate that input.
Okay. And then Steve, I saw your hand. Did you have an additional question?
No, I guess I was just, I think it sounds like Dexter said that the questions around heat recovery and interacting with Green Mountain Power, that those are definitely on the, on his radar. But I guess I'm less sure about what's involved or how much involved and what it might cost for them to do an analysis of the greenhouse gas emissions, and whether that's just, whether he's saying, yes, thanks for asking, we'll do that, or whether he's saying, thanks for your question, but I'm not sure that that's included in the contract or otherwise could be done. So anyway, I'm curious, a little more curious about that, and whether that's something that he'll just plan to do, or something that the committee needs to formally request, and whether that would involve a change order of some sort. So I guess a more specific question about that. Thanks.
Yeah, so that's not part of our contract, but I will just add that, these technologies are studied widely in the industry. And so from my standpoint, it's just a general knowledge that we're picking a winner. But if it was something that the town was interested in, we could certainly make that analysis part of our study. I think we're also going to be recommending some looking at SSO markets more closely, and the energy and heat recovery sides of it go beyond what we had anticipated as well. So things get a little complicated as we go that way, but I think that there are a number of things that can be looked at more closely. Like that's back on my screen.
So is the green
that Dexter, you would be looking for a change order for those additional services that you just enumerated?
Yeah.
Thank you.
Okay. Are there any additional questions for Dexter? Judy?
Yeah, I would be interested in following up with information on that wet test, but if it's just a matter of, getting sent some references, that would be great. Or again, if you can send them to Dan and he can forward them, whatever's easiest.
Yeah, I'll touch base with Dan, but we'll follow up with that in some way.
Okay, thank you.
Okay. Anything else? All right. Well, Dexter and Steve, thank you both for being here today and providing the presentation, Dexter. And we'll look forward to more information as you continue evaluating our system.
All right. Thank you.
Thanks, Dexter.
Thank you.
Okay. So I added to the agenda just a brief discussion about the capital budget timeline. In our packet for this meeting we were provided a capital improvements budget timeline, and it does mention in the under the October, an additional meeting of the committee may be needed to be scheduled in October, early November, depending on amount of work to be done. So next meeting on the 8th, that's right, 8th of October, Thursday the 8th, we'll get our first look, the first draft of the capital budget. We'll need to finalize that recommendation at the next meeting in November. So there's a possibility we may need a second meeting in October, depending on, how that goes. And just, to kind of get something on everyone's calendar. I thought it would be a good idea maybe to pencil something in. I was going to suggest Thursday the 22nd for 9 a.m. and just see if that worked for everyone's schedule. Now, if we are able to do everything we need to do on the 8th and the 12th, we certainly can just cancel that meeting, but I wondered if it would be possible to pencil that in just in case we need it. Does anyone have any conflicts with the 22nd at 9? Kathleen and Dan, does that work for you?
The only thing I can tell you is that I'm having hip surgery on the 19th, so I might be sitting in a chair watching you.
Okay. Kathleen, does that work okay? Just as a placeholder for now in case we need it?
Yes.
Okay. All right. So I'm just going to mark that on my calendar. Okay. So committee member concerns. I'll just start at the top and go around. Gary, did you have anything?
No.
Okay. Judy?
No.
Okay. Candy? You're still muted, Candy.
Thank you. Not a concern, but a question. The capital budget is 1 year. Do we ever look ahead multiple years?
The capital budget reviewed by the committee is a 5-year plan.
Oh, okay. It said FY22, so okay, good, thank you.
Yes, but the spreadsheet does have projected expenses over 5 years. So we are looking at, we're not just looking at 1 year, we are looking at anticipated capital expenditures over 5 years.
Okay, good, thank you.
Yeah, sure.
I forgot from last year.
Eric, did you have anything?
Nope.
Okay, Luther?
Just to reiterate the issue, several properties across town are not mowing the green sidewalk, cross street. There's several, so I'd like to understand if there's any recourse the town can take, or just to reach out to those individuals and ask nicely. That's all.
Thank you for that.
Okay, so I'm all set. I don't have anything. Staff, Beth, Dan, Kathleen, Jackie, Bob, Bill, anything to bring up for the committee?
No.
Okay. All right, I think we're good to adjourn until our next meeting in October. Can someone make a motion?
No move. Second.
Okay, I'll give Judy the motion, Gary the second on that one. Anyone opposed to adjourning? Okay. All right, thank you, everyone. Good meeting. We'll see you all in October. Thank you.